Let's take a look at one last example. Sand is being pumped from a conveyor belt at a rate of 1.2 meters cubed per minute and forms a pile in the shape of a cone whose base diameter and height are always equal. So there's a constant ratio that always exists. How fast is the height of the pile growing when the pile is 3 meters high? So I got the sand forming a cone where the diameter and the height are always equal. I know that the radius is the same as, the diameter is the same as 2r. And I know that the radius would be the same as 1/2 of h in this case. I also know the volume of the cone, just like in the last question, is going to equal 1/3 pi r squared h, where v is volume, r is the radius, h is the height, and t is time. I also know, based on the information, that my volume over time is going to be 1.2 meters cubed per minute. I know I'm doing this when the height is 3. And I know I'm trying to figure out the change in height over time, dh over dt. So if my volume is equal to 1/3 pi r squared h, my r value is 1/3, my r value is 1/2 h. I'm going to sub that in to eliminate r. My volume, just like in the last case, is going to be pi over 12 h cubed. And when I differentiate in terms of time, dv over dt is going to equal pi over 12 and then 3h squared multiplied by dh over dt. I'm going to simplify this, dividing both those by 3. And I'm going to sub in the values that I know. 1.2 is equal to pi over 4 times 3 squared times dh over dt. Now, I'm going to rewrite 1.2 as a fraction. So I'm going to say that would be the same as 12 over 10 to get rid of the decimal, or 6 over 5. I'm going to square that 3 to get 9. So I have 9 pi over 4 times dH over dt. And that means that if I'm dividing both sides by 9 pi over 4, I'm multiplying by the reciprocal. So dH over dt is going to equal 6 over 5 multiplied by 4 over 9 pi, which is 24 over 45 pi. And I can divide both those by 3, and I get 8 over 15 pi meters per minute. How fast is the height of the pile growing when the pile is 3 meters high? The height of the pile is growing at a rate of 8 over 15 pi meters per minute when the pile is 3 meters high. And that's it.